All right, this is number 16 on page 241. It is really hard to understand what's going on in this shape. And so what I did is I split it up. And so what looked like a really easy problem actually is harder because what we need to get correct is we need to have basically this, and this, the whole line, not just parts of lines, to equal this, and the whole line. Okay, so we're going to start with the easy parts of it and then go to the harder part. Okay, so for sure, we can start with the given. And so I'm going to get that done here, and then you guys can kind of guide me where we get confused or what we can do easy. Because there's got to be easy. We do know that it's going to be side, 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 right? Because we're still at the point where I'm telling you all that stuff. And so I might have to zoom out here so we can get it all the good stuff in. Okay. So the given, and there are three givens, Wx is congruent to Vz, Wy congruent to Vy, and Yz is congruent to Yx. Yeah, there it is. I lost it. Okay, it's already marked for you on the shape. And so the important one that I know I can use right off the bat, and this is important to be able to detect, is I lost my black marker pen. Okay. The important one is Wx and Vz. That gives me a side. So this gives me a side already. Okay, so that's the most important one. These other two we're going to have to do something with. Okay, so this is all given, of course. And if I do that, I like to kind of draw a line so we can, so we kind of clump it up. I'm going to have to use the other stuff in the given. They're not trying to trick you. They're not going to give you stuff you don't use. Okay. And I guess I need to write the prove. We're going to prove that triangle LMJ is congruent to triangle JK. That's 15. That is 15, and so that would not be provable, right? So, thank you. That's VWX, right? Yeah. Is congruent to triangle WVZ. Yeah. Okay, I'm glad you did that. Here we go. So again, I'm going to look at this to kind of plan things out. We got here and here. I don't really need this segment. I don't really need this segment. I need the whole segment. And so we'll get to that, but I want to do easy stuff first. I think that I can do this right here. For lack of a, even though there's only three sides, I'm going to have to use 4 here. I think we can do this. W, nope, that makes a shadow if I do it like that. So WV is congruent to WV. This part's not the hard part, is it? That's reflexive. And so that gives me another side, right? All right, so I got to go back to this part. What theorem or postulate or rule or something would allow us to put together two smaller lines? Segment addition postulate. So that's what I'm going to need to do And I'm going to kind of show you how that works. Okay. And this first thing I'm going to do is very technical. The first thing I'm going to do is I'm going to write this. WY equals VY. YZ equals YX. Okay, I didn't put the line above it because I have changed congruent to equal, and it's no longer line segments, it's now basically the distance between the 2 points. Because unfortunately, the segment addition postulate is basically in algebra, not in geometry. And so there's a rule that switches from geometry to algebra, and it is just the definition of congruency. Okay, some people do definition of segment congruency. There's a bunch of things. I just do definition of congruency. If this is a small detail that you leave out of a proof like this, it's not the end of the world, especially where you guys are in your proof development. But technically, we got to switch it to an algebra problem. And once we switch it to an algebra problem, I see your hand. Once we switch it to an algebra problem, we get to use all of our algebra properties, like adding and subtracting and multiplying and dividing. Okay, question, yes?
So, why did you rewrite the given? Like, those are both given, so...
Why did I rewrite the given? The given was in congruency. Technically speaking, I have to switch it to equal, so I can use all the algebra properties that I'm about to use. If this is the part you don't understand, it's not a big deal, but I don't want to give you I want to give you the fully right way, and then I'm going to kind of show you what is okay for our point. But I want to show you the high level that it could be, and then we're going to kind of focus on what we're going to get done. Okay. And so we talked about the segment addition, and now I'm going to do the segment addition postulate. And so I'm going to add basically VY and YX, and I'm going to add WY and YZ. So here we go, VY plus YX. I think, right? Is that right? Yes. VY, YX. So VY plus YX equals, what would that be, VX? And I'm going to do the other one, WY plus, what is it, YZ is going to equal WZ. Now this is an easier one to understand. I'm just adding them together. This step is hard to understand. It just switches congruency to equal. It allows me to add and subtract and stuff.
What's the first letter on the bottom one?
W. Right here?
Yeah.
Yeah, W. And this is the segment addition postulate. That's from that first chapter. Okay. So we are almost there, but it does take a couple steps. Okay, a lot of people, if you got this far, honestly, on your own, but didn't quite know what to do with it, that's fine. What I do at this point is, well, I'm going to look back up at my given. It says WY equals VZ, okay? So here is what I'm going to do here. I'm going to do, let's see, WY equals VY, right? WY equals VY. So I'm going to do this right here. VY plus YX equals WZ. Okay, let's think about what I just did. VY and WY are congruent, right? Are equal. YX and YZ are equal. So what allows me to switch out wy for vy? Substitution property, right? Okay. And again, this is one of our properties that we use for algebra, right? And that's why we're here. So substitution property. Okay? And why would I just do that? Why would I substitute? Okay. Okay. So there's different ways to do this, and it based on order. The way I'm doing it, I'm going to use substitution again. If you do it in another way, it could be the transitive, and there would be a debate on what to do on this. But basically, I'm going to look at this right here. This matches this, doesn't it? So I'm going to do this again. Vx equals Wz. And basically I substituted again, didn't I? If I wrote it in a different order, it could have been the transitive property. Some would argue that it is already the transitive property, but that's fine. I'm not going to nitpick that aspect. So is this what I ultimately want? Do I ultimately want Vx is congruent to Wz? Is that not what I want? So Vx is congruent to Wz, right? That's what I want. Oh, did I do it in the wrong order? No, Wz, Vx. No, that's right. And so, again, this is kind of a nitpicky thing. I'm switching it back into geometry. So, if you did all of this in 1 or 2 steps, I'm impressed. Am I going to put something this hard on the test? Probably not. But I do want you to show you where it's going. And so, this statement right here gives me my last side, and so I can finish off with side, 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 and I just do this little VWX congruency. Okay. And again, if this is hard to understand, but this is kind of where algebra and geometry meet, and so I needed to do at least 1, maybe 2 examples of this, where we get to use our algebra to finish stuff. Okay. All right, so that's that one. Let's grade the rest.